Hey guys, and welcome back to another video. In this video, we will be talking about 3.1 angles. Alright, so let's get right into it. Alright, so to begin with, let's talk about some common vocabulary that we're going to be using for throughout this unit. So, suppose we have some angle theta as such. Okay, so this array right here, this is known as the terminal side of the angle. Okay, and then this ray right here is known as standard position, right? And that's basically when the terminal side is on the positive x-axis. So when the terminal side is on the positive x-axis, which is like right here, that's known as standard position. And then the angle formed between those two rays, that's the angle theta. Okay? All right, good. So, and then right here, we're starting off at 0 degrees, and then you go to 90 degrees. This is 180 degrees. This is 270 degrees, and then back to 360 degrees. Okay? And these angles, right, 0, 90, 180, 270, 360, these are known as quadrantal angles. So, some more vocab. Put it right here. Quadrantal angles. Quadrantal angles are basically angles whose terminal side lies on an axis. Okay? They're angles whose terminal side lies on an axis. So, for example, 0 degrees and 360 degrees, they both lie the terminal side on the positive x-axis. 90 degrees, the terminal side lies on the positive y-axis. 180 degrees, it lies on the negative x-axis, and then 270 degrees, the negative y-axis. Okay? Alright, good. So now, with that vocab in mind and like stuff, we can do some practice problems. So, we'll do example 1. So, let's say you want to sketch each angle. Alright, so the first one, 45 degrees. Okay? So I just like erase this stuff real quick. And we want to sketch 45 degrees. So, okay. So remember that this right here, this is 0 degrees, and then this is 90 degrees. And so 45 degrees is right in between these. So always start off by drawing your standard position first, right? So always start off with standard position, and then draw your terminal side. So we're going to just write halfway through, and then this is 45 degrees. Okay? Cool. So next, we'll sketch 170 degrees. And it doesn't have to be exact, right? It just has to be in the correct quadrant. It has to be close enough. So again, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So 170, that's between 90 and 180, right? So it's going to be in this quadrant. So again, first step, always draw your standard position first, and then we can draw 170. So it's going to look something like that, right? So this angle right here is 170 degrees. All right, nice. Let's do one more. Well, what if we want to sketch 340 degrees? So again, we can just sketch it real quick. This is 0, 90, 180, 270, and then 360 degrees. Okay, so 340, that's in between 270 and 360 degrees. So it's going to be in quadrant 4. So again, start off with your center position, and you're going to rotate it like this It's going to look something like that, right? And so now be careful, because 340 degrees is the outer angle. It's not the inner angle, okay? So we're going to say that this whole angle right here is 340 degrees. The inner angle would actually be 360 minus 340, which is 20, okay? All right, good. All right, so now let's move on to coterminal angles. Coterminal angles. All right. So they're essentially just angles whose terminal side lies or like lands on the same spot. Right? So what do I mean by that? So for example, let's say we had some angle that looks like this, right? Theta. So if you rotate theta by 360 degrees, right? So you go to like one full revolution, you're gonna end up at the same angle. So, and then this is the terminal side, right? So the terminal side of the new angle is going to be the same as the terminal side of our original angle. And so those two angles are now known as coterminal angles. All right. And so then the way you find these is you just have to add or subtract multiples of 360 degrees. And your final angle should always be between 0 degrees and 360 degrees. All right. All right, nice. So let's do some examples. So you want to find coterminal angle. Find least positive coterminal angle, right? And if you that's just the angle symbol, right? That just means angle. But anyway, so let's say you want to find coterminal angle for 415 degrees, right? So remember, we just have to add or subtract multiples of 360. So for here, we know that 415 degrees is greater than 360 degrees. So let's subtract 360 from this one time. And what do we get? Let's see, we get 55 degrees. And you know you're done when your final angle is between 360 and 0. Okay, and 55 degrees falls in this range, so this is the least positive coterminal angle. Boom. All right, let's do another one. Let's say we had 370 degrees. So again, this is like bigger than 360, so we can subtract 360 from this one time, and we get 10 degrees. All right, and lastly, let's do 1000 degrees. So for this one, you might notice that if we subtract 360 one time, let's see, we have 6040 degrees, but that's still outside of this, so you have to do it one more time. And you get 64 minus 36 is 28. Yeah. And so now this is in our range, so this works. So for these examples, it was pretty easy, right? We had to subtract at most 2 multiples of 360. But if you had like a really like bigger angle, like in a 10,000, like for example, if you had like 2,715 degrees, right? That's like going to take a long time to subtract multiples of 360 from. So what you could do is you could just divide this by 100, 360 degrees, see however many multiples there are. So like you probably like, let's just say it's like some number, I'm not sure, but then like some like decimal, right? So then you have to do 360 x. So you take the angle 2715 degrees minus 360 degrees times x, so whatever that is, and that should land in this range. That's equal to your answer. All right, but yeah, That's how you find coterminal angles. Alright. So now let's move on to radians. So radians are essentially just another way of measuring angles, right? So before we were using degrees, so radians are another way to another units for angles. So let's say we had some circle in the plane, right? And let's say we had an angle in standard position, and then we like draw it like that much, right? And this is theta. So notice how it subtends this arc of the circle right here, right? It subtends that arc of the circle. And we know that from here to there, like from here to where it intercepts the circle, that's just the radius of the circle. So we'll call that r. And let's just say that this arc length, the length of this arc, is also r, right? Let's just say. So then we can express theta in radians as 1 radian. Okay? So let's do another example. So for example, now let's say we have the same unit circle, or any circle in the plane. And now let's say we make it that terminal side land there. And let's just say this length right here is still r, right? But now let's say that this length right here, right, where it like subtends, let's say that length is 2r. Okay? So that length is 2r, so then theta, that means, is going to be equal to 2 radians. So now maybe you see a pattern already, but if you don't, we can do one more example. And this time we will have the circle and an angle in position, and this time we'll go all the way around, right? So we'll go all the way around and land back where we started. So how many radians is this angle? Because we know that this is 360 degrees, right? Because it's one full revolution. But how many radians is that? Well, if we go back here, we notice that when the length of the arc was 1 radian, or was 1 radius, right? Then that means that the theta was 1 radian. When the length was 2 radiuses, right? Then the theta was 2 radians. So here we have to see how many radiuses is the arc length. And this is just one full circle, so we just look at the circumference formula. 2 pi r is the length of this whole circumference. And so that means that we have 2 pi radians, because we have 2 pi radiuses. So theta in this case is equal to 2 pi radians. Okay? Alright, good. So for radians, so remember for degrees, theta was had to be between 360 degrees and 0 degrees. For radians, theta has to be between 2 pi radians and 0 radians. Alright? So that's basically radians. There's another way of measuring angles. Alright? Cool. So now let's do let's talk about converting from radians to degrees and degrees to radians. So if you want to convert from radians to degrees, right? So notice how in the previous example, we saw how 2 pi radians is equal to 360 degrees, right? And also for radians, you don't need to have any units, right? So if I got rid of this and there's like no degree symbol, then it's defaulted to radians. So we could just say that 2 pi is equal to 360. This means that 2 pi radians is equal to 360 degrees. All right, but anyway, if we divide both sides of this by 2, we get that pi radians is equal to 180 degrees. And so this is what we're going to use as a conversion factor, right? Because if we multiply by pi over 180 degrees or 180 degrees over pi, this is just 1, right? Since pi is equal to 180, so anything divided by itself is 1. So multiplying by either of these fractions is just the same thing as multiplying by 1. So it doesn't change the original value. So then, with that being said, if you want to go from radians to degrees, let's say you have some angle theta that's in radians. And then in order to convert it to degrees, you're going to multiply by 180 degrees over pi. All right, and that's because you want the radians to cancel, right? Because this is pi radians, so you want radians to cancel, and you want degrees left over. That's what's in the numerator. So this is the conversion for radians to degrees, and then if you want to go from degrees to radians, you just multiply by the reciprocal. So you multiply theta by pi over 180 degrees, because now the degrees cancel and you have radians left over. All right? Okay, good. So now let's do some practice, some examples. All right. So let's convert the following degree measures. All right, part A, 45 degrees. So we starting in degrees, so that means we want to go to radians. So to go to radians, remember you have to multiply by pi over 180 degrees, because the degrees cancel. And then simplifying this, 45 and 180, this just simplifies to 4, and this just goes to 1. So then overall, you're left with pi over 4. So 45 degrees is equal to pi over 4 radians. All right, nice. Part B, let's convert pi over 3 radians to degrees. And the way that you know it's radians is because there's no degree symbol, right? There's no units. So there's like no units and there's no degree symbol, then it's radians. Okay. But if you want to convert this to degrees, you're going to multiply by 180 degrees over pi. The pi's cancel, and then you're left with 180 degrees over 3, which is 60 degrees. So pi over 3 radians is equal to 60 degrees. All right, let's do one more. 270 degrees. So converting this to radians, because they're in degrees, we'll multiply by pi over 180 degrees. And what does this give us? So degrees cancel. And then 270 over 180, this simplifies to 3 and then 2. So 270 degrees is equal to 3 pi over 2 radians. All right. But yeah, that's pretty much it for this lesson. If you enjoyed the video, please subscribe and make sure to leave a like. I'll see you guys in the next video.